Liter of crude oil weight 9.6 Newton. Calculate its specific weight, density and specific gravity. So what is given in this question? So volume, that is equal to 1 liter. So we know that 1 liter, that is equal to 1 by 1000 meter cube. So that is equal to 10 to the power minus 3 meter cube. And weight is given, that is equal to mg, that is given in this question 9.6 Newton. Calculate specific weight, density and specific gravity. So we know that the formula of specific weight, omega, that is equal to weight of the fluid by volume of the fluid. So weight of the fluid mg by volume of the fluid. So weight of the fluid which is given, that is 9.6, and volume of the fluid, that is equal to 10 to the power minus 3. So that is equal to 9600 Newton per meter cube. So this will be the one answer. Second answer, that is density. You have to calculate the density. We know that omega, that is the specific weight, that is equal to rho into g. So rho, that is equal to omega by g. So from here omega, that is, we know that is 9600 density, that g, the g is the gravitational acceleration, this is 9.81. If you calculate that value, so this value will be 978.6 kg per meter cube. Okay, so now if you want to calculate the specific gravity, is, we know that specific gravity, it is the density of the fluid by density of the water. Okay, so what is the density of the fluid? That is given. So the density of the fluid, so that is 978.6 by density of water, that is 1000. So if you want to calculate this value, that is equal to 0.97866. So this a plate 0.025 mm distance from a fixed plate moves at 50 centimeter per second and requires a force of 1.471 Newton per meter square to maintain this speed. Determine fluid viscosity between the plates in the poise. You have to find out the viscosity in this poise. Okay, given dy, that is equal to 0.025 mm, that is equal to 0.025 into 10 to the power minus 3 meter. Du, that is 50 centimeter per second, which is given, that is equal to 0.5 meter per second. Tau, which is also given, that is equal to 1.471 Newton per meter square. So you have to calculate mu. So from Newton's law of viscosity, we know that is equal to mu du by dy. Okay, so from here tau, which is given in this question, so 1.471, and mu, you have to determine this mu, and du, which is given as 0.5, and dy, that is 0.025 into 10 to the power minus 3. Okay, so from here mu, that is equal to 1.471 divided by 0.5 divided by 0.025 into 10 to the power minus 3. So from here, what is the value of that? So here 0.5 divided by 0.025 into 10 to the power minus 3. So okay, so 1.471 divided by mr. Okay, so this will be, what is the value of that? So 7.3 into 10 to the power minus 5 Newton second per meter square. So if you want to convert it into poise, you have to multiply it by 10 with that to convert it poise. So what is the answer of this? So 7.3 into 10 to the power minus 4 poise. Determine the intensity of shear of an oil having viscosity, that is equal to 1.2 poise, and is used for lubrication in the clearance between a 10 cm diameter shaft and its journal bearing. The clearance is given, that is 1.0 mm, and the shaft rotates at 200 rpm. So what is given in this question? So mu, that is equal to 1.2 poise, that is 0.12 Newton second per meter square. Diameter is given, that is 10 cm, that is equal to 0.1 meter. Clearance, that is equal to 1 mm, that is equal to 1 into 10 to the power minus 3 meter. Revolution, that is 200 rpm. So you have to calculate the tau. So as per Newton's law of viscosity, tau equal to, we know that mu into du by dy. So what is the value of mu? Mu, which is given, that is 0.12. So 0.12 into du. What is the value of du? Du is not given in this paper, in this question. So how to calculate the u? So du, we know that pi d n by 60. So this is the formula. So pi into diameter, that is equal to 0.1 mm, 1 meter by into 200 divided by 60. Okay, so if you calculate that value, this value will be 1.047. Now, so put the value here, 1.047 divided by dy. What is the value of dy? That is the 1 into 10 to the power minus 3. So 1 into 10 to the power minus 3. So if you calculate this value, so this value will be so here 1.047 into 0.12 divided by 0.001. So this is equal to 125.64 Newton per meter square. So this will be our final answer. So two plates are placed at a distance of 0.15 mm apart. The lower plate is fixed while the upper plate, having surface area, that is 1 meter square, is pulled at 0.3 meter per second. Find the force and power required to maintain this speed if the fluid separating them is having viscosity 1.5 poise. So what is given in this question? So given dy that is equal to 0.15 mm, area that is equal to 1.0 meter square, du that is given 0.3 meter per second, mu 1.5 poise that is 0.15 Newton second per meter square. You have to calculate the force and power. So how to calculate that? So here we know that from Newton's law of viscosity, tau that is equal to mu into du by dy. So from here tau will be mu that is equal to 0.15 du that is 0.3 dy that is 0.15 into 10 to the power minus 3. So it will convert it into meter, that is 0.15 into 10 to the power minus 3 meter. Okay, so that is will be, so this is will be 0.3 into 10 to the power 3 Newton per meter square. So if you calculate that value, that is 300 Newton per meter square. Okay, now if you want to calculate the force, if the formula is tau into area. Okay, so what is the value of tau? That is 300 and area that is 1. So 300 Newton. So this will be the one answer. And the another answer, you have to calculate the power also. So how to calculate this power? That is, so power P, we know that formula, F into du. So what is the value of F? That is 300 into du, that is given, that is 0.3. So the unit will be joule per second. So this will be 90 joule per second. We know that 90 joule per second means what? So this will be the second answer. An oil film of thickness 1.5 mm is used for lubrication between a square plate of size 0.9 meter into 0.9 meter and an inclined plane having an angle of inclination that is 20 degree. The weight of the square is 392.4 Newton and it slide down the plane with a uniform velocity of 0.2 meter per second. Find the dynamic viscosity of the oil. So what is given in this question? dy that is equal to 1.5 mm that is equal to 1.5 into 10 to the power minus 3 meter, area that is 0.9 into 0.9 meter square, theta that is angle of inclination that is 20 degree, weight that is equal to 392.4 Newton, u that is equal to 0.2 meter per second. So you have to calculate the mu. So we know that from Newton's law of viscosity, tau that is equal to mu into du by dy. So how to calculate this tau? So tau, we know that tau that is equal to force per unit area, shear force per unit area. So how to calculate this shear force? So this will be the force, this is W sin theta, that is theta. So this is the W cos theta component and this is the W sin theta component. So W sin theta by area. So what is the value of W? W is 392.4. So 392.4 and sin 20 degree, theta is 20 degree by area, that is the 0.9 into 0.9. Okay, so if you calculate that value, this value will be 165.69 Newton per meter square. Now put this value here. So if you want to calculate the viscosity, mu that is equal to tau upon du by dy. So tau, what is the value of tau? So tau that is equal to 165.69 divided by du. What is the value of du? That is 0.2. And what is the value of dy? That is 1.5 into 10 to the power minus 3. So if you calculate this value, this value will be 1.24 2 Newton second per meter square. So if you want to calculate this into poise, that is 12.42 poise. So just multiply it with 10. So the answer will be 12.42 poise. So this will be our answer. In a stream of glycerin in motion, at a certain point, the velocity gradient is 0.25 meter per second per meter. The mass density of the fluid is 1268.4 kg per cubic meter and kinematic viscosity, that is 6.3 into 10 to the power minus 4 square meter per second. Calculate the shear stress at the point. So what is given in this question? du by dy that is equal to 0.25 meter per second per meter, density that is 1268.4 kg per meter cube, nu that is equal to 6.30 into 10 to the power minus 4 meter square per second. So you have to calculate the value of tau. So what is the value of tau? We know that from Newton's law of viscosity, tau that is equal to mu into du by dy. So but we know that nu that is equal to mu by rho, that is very important formula. So from here mu that is equal to nu into rho. So put the value and mu value here, mu into, so rho into du by dy. So mu, what is the value of mu? That is the kinetic viscosity, that is 6.30 into 10 to the power minus 4 meter square per second. What is the value of density? That is 1268.4 into du by dy. What is given? That is equal to 0.25. So if you try to calculate this here, so what is the value of that? That is 6.3 into 10 to the power minus 4 into 1268.4 into 0.25. So this is 0.199. So this is approx equal to 0.2. So 0.2 Newton per meter square. So this will be our answer of the shear stress. Find the kinematic viscosity of an oil having density 980 kg per meter cube when a certain point when at a certain point in the oil the shear stress is 0.25 Newton per meter square and the velocity gradient 0.3 per second. So given what is given in this question, so rho that is equal to 980 kg per meter cube, shear stress that is 0.25 Newton per meter square, velocity gradient 0.3 per second. So you have to calculate nu. So from Newton's law of viscosity we know that tau that is equal to mu du by dy. So from here what is the value of mu? That is equal to tau upon du by dy. So tau what is the value of tau? That is 0.25 and du by dy that is 0.3. So if you want to calculate this value will be 0.833 Newton second per meter square. Now if you want to calculate the nu, that is the formula mu by rho. So what is the value of mu? That is 0.833 and what is the value of density rho? That is 980 kg per meter cube. So if you want to calculate this value will be so this is 0.833 divided by 980. So this is equal to 0.00085 and meter square per second. So this is equal to 8.5 5 into 10 to the power minus 4 meter square per second. So this will be equal to 8.5 into, so this will be centimeter square per second. So 8.5 centimeters per second. So it is also known as Stokes. So the kinetic viscosity will be 8.5 Stokes. So this will be our answer. Determine the specific gravity of a fluid having viscosity 0.07 poise and kinematic viscosity that is 0.042 Stokes. So what is given in this question? Mu that is equal to 0.7 poise. So this will be equal to 0.007 Newton second per meter square. Nu which is given in this question that is 0.042 Stokes that is equal to 0.042 centimeter square per second. So that is equal to 0.042 into 10 to the power minus 4 meter square per second. So you have to find out the specific gravity is. So we know that nu that is equal to mu by rho. So from here rho that is equal to mu by nu. So put the value here. So mu what is the value of mu? That is 0.007 and nu that is 0.042 into 10 to the power minus 4. So here so 0.007 divided by 0.042 into 10 to the power minus 4. So this will be 166.67 kg per meter cube. Okay. Now if you want to calculate the specific gravity is, that is density of fluid by density of standard fluid. So density of water. So what is the density of fluid? That is 166.67 divided by 1000. So if you want to calculate this value, this will be 1.67. So the specific gravity is the answer will be 1.67. There is no unit. Determine the viscosity of a liquid having kinematic viscosity 6 Stokes and specific gravity 2.0. So what is given? So nu that is equal to 6 Stokes, that is 6 centimeter square per second, that is equal to 6 into 10 to the power minus 4 meter square per second. And specific gravity S is given, that is 2. You have to calculate the value of mu. So specific gravity is equal to, we know that density of fluid by density of standard fluid. So density of fluid that is so from here, so specific gravity that is 2 is given, that is density of fluid by density of standard fluid that is 1 water that is 1000. So from here you can get the density of the fluid that is 2000 kg per meter cube. Okay. So now if you want to calculate the viscosity, we know that nu that is equal to mu by rho. So from here mu that is equal to nu into rho. So what is the value of nu value which is given, that is 6 into 10 to the power minus 4. 6 into 10 to the power minus 4. And what is the value of density? That is 2000. So if you multiply it, so 2000, 6 into 10 to the power minus 4. So 6 into 10 to the power minus 4 into 2000. So this value will be 1.2 Newton second per meter square. And if you want to calculate into it poise, so you have to multiply by 10. So 12 poise. So the answer will be 12 poise. If the velocity distribution of a fluid over a plate is given by u that is equal to 3 by 4 y minus y square, where u is the velocity in meter per second at a distance of y meters above the plate, determine the shear stress at y equal to 0.15 meter. Take dynamic viscosity of the fluid as 8.5 into 10 to the power minus 5 kg second per meter square. So what is given in this question? So u, the velocity profile 3 by 4 y minus y square, y that is equal to 0.15 meter, mu that is 8.5 into 10 to the power minus 5 kg second per meter square. You have to calculate the value of tau. So tau that is equal to, we know that tau that is equal to mu into du by dy in which location? At y equal to 0.15 location. So mu, the velocity with respect to y. So what is the derivative with respect to y? So that is 3 by 4 minus 2y. Y equal to 0.15. So put the value here. So mu that is 8.5 into 10 to the power minus 5 into 3 by 4 minus 2 into y, that is 0.15. So if you calculate this value will be 3.825 into 10 to the power minus 5 kgf per meter square. So the answer of tau, that will be 3.825 into 10 to the power minus 5 kg per meter square. So this will be our answer. An oil of viscosity 5 poise is used for lubrication between a shaft and sleeve. The diameter of shaft is 0.5 meter and it rotates at 200 rpm. Calculate the power lost in the oil of a sleeve length of 100 mm. The thickness of the oil film is 1 mm. So what is given in this question? So mu, that is equal to 5 poise, that is 0.5 Newton second per meter square. Diameter, that is 0.5 meter. RPM, that is 200. Length, that is 0.1 meter. And clearance, that is 1 mm, that is equal to 0.001 meter. So you have to calculate the power. Okay. So if you want to calculate shear stress, tau, that is equal to mu into du by dy. So here mu is given, dy is given. So you have to calculate the value of u. So u, we know that u, that is equal to pi d n by 60. So what is the value pi into d? What is the value of d? That is 0.5 into n, that is 200 rpm. So 200 divided by 60. So if you calculate this value will be 5.24 meter per second. So here just put the value here. So mu, what is the value of mu? That is 0.5. du, that is 5.24, and dy, what is the value of dy? That is 0.001. So this value will be 2618 Newton per meter square. Okay. So now if you want to calculate the force, that is the formula is tau, shear stress into area. So shear stress, that is tau into what is the area? That is pi into d into L. So tau, what is the value of tau? That is 2618 into pi into d, what is the diameter? That is 0.5 into length. So length, that is 0.1. So 0.1. So the value will be 411.23 Newton. Now if you want to calculate, so what is the torque here? So if you want to calculate the torque, that is force into d by 2. Okay, so what is the value of force? That is 411.23, and what is diameter? That is 0.5 divided by 2. So this answer will be 102.808 unit will be Newton into meter. Now if you want to calculate the power, so power, that is equal to, we know the formula, 2 pi nt by 60. So let's put the value here. So 2 pi n, that is 200, torque, that is 102.808 divided by 60. So the answer will be 2.153 kilowatt. So the power, that is will be 2.153 kilowatt. So this will be our answer. Velocity distribution over a plate is given by u equal to 2 by 3 y minus y square, in which u is the velocity in meter per second at a distance of y meter above the plate. Determine the shear stress at y equal to 0, 0.1 and 0.2 meter. Take mu, that is equal to 6 poise. So what is the value of mu? Mu, that is equal to 6 poise. So this will be 0.6 Newton second per meter square. So what is given in this question? So u, that is equal to 2 by 3 y minus y square, y1 that is equal to 0, you have to calculate with respect to tau 1, y2 that is equal to 0.1, you have to calculate the value of tau 2, y3 that is equal to 0.2 with respect to, you have to calculate the value of tau 3. Okay. So first calculate. So u, that is given, that is 2 by 3 y minus y square. So derivative with respect to y, so du by dy will be 2 by 3 minus 2 into y. So now if you want to calculate the value of tau 1 that is equal to mu into du by dy at y equal to 0. So tau 1, that is what is the value of mu? That is 0.6 into du by dy at y equal to 0, 2 by 3 minus 2y at y equal to 0. So if you put the value here, the answer will be 0.4 Newton per meter square. So this will be one answer. Now tau 2. So tau 2, that is equal to mu into du by dy at y equal to 0.1. So mu, that is 0.6 into 2 by 3 minus 2 into 0.1. So the answer will be 0.28 Newton per meter square. So this will be the second answer. And the third answer will be tau 2. So the third answer will be tau 3, that is equal to mu into du by dy at y equal to 0.2. So tau, that is 0.6 into 2 by 3 minus 2 into 0.2. Okay. So from here, what is the value of that? That value will be 0.16 Newton per meter square. So tau 3 will be 0.16 Newton per meter square. So this will be our answer. The velocity distribution over a plate is given by u equal to 2 by 3 y minus y square, in which u is the velocity in meter per second at a distance of y meter above the plate. Find the distance in meter above the plate at which the shear stress is 0. So you have to calculate the value of y where the shear stress, that is equal to 0. Okay. So we know that tau, that is equal to mu into du by dy. So from here, tau, that is equal to mu into, what is the value of du by dy? That is 2 by 3 minus 2y. Now put the value here, tau equal to 0, that is mu into 2 by 3 minus 2y. So from here, that is 2 by 3 minus 2y, that is equal to 0. So from here, 2y, that is equal to 2 by 3. So y, that is equal to 1 by 3. So that is equal to 0.33 meter. So the answer will be 0.33. The velocity profile of a viscous fluid over a plate is parabolic with vertex 20 cm from the plate, where the velocity is 120 cm per second. Calculate the velocity gradient and shear stress at distance of 0, 5 and 15 cm from the plate given the viscosity of the fluid that is equal to 6 poise. So what is given? There is a parabolic velocity profile. So consider the parabolic velocity profile that is equal to ay square plus by plus c, and viscosity that is 6 poise that is given, that is 0.6 Newton second per meter square. Now the boundary condition at y equal to 0 equal to 0, this is the no-slip boundary condition. At y equal to 20 cm equal to 120 cm, this is given in this question. Okay, so and the third boundary condition, this is the second boundary condition, and third boundary condition, that is y equal to 20 cm, the velocity gradient, this will be equal to 0. So if you apply these three boundary condition in that equation, so in this equation the equation will be the final equation will be equal to minus of 0.3 y square plus 12 y. So from here you get the a equal to 0, minus of 0.3, b equal to 12, and c value will be 0. So from here you get this is the final equation. Now if you want to calculate the velocity gradient at y equal to 0, so velocity gradient du by dy, so du by dy at y equal to 0, so this will be minus of 0.3 into y plus 12. So minus of 0.3 into 0 plus 12. So there the answer will be 12 per second. So this is one answer. Now if you want to calculate the shear stress at that location, tau that is equal to mu du by dy at y equal to 0. So this will be, so mu value that is 0.6 given into 12. So the answer will be 7.2 Newton per meter square. So this is the answer. Now if you want to calculate the velocity gradient at location 5, so du by dy, so du by dy at y equal to 5 centimeters. So 5 centimeter means 5 centimeters. So y equal to 5 centimeters. So this is equal to 0.6 minus 0.6 into 15 plus 12. So the answer will be 3 per second, and the shear stress tau that is equal to mu du by dy at y equal to 15 centimeter. So what is the value of mu? That is 0.6, and this is 3. So this will be 1.8 Newton per meter square. So this is for 15 centimeter. Okay, and what is the value of velocity gradient? So this is one answer. Okay, and what is the velocity gradient with respect to at y equal to 15 or y equal to 5 centimeter? So at y equal to 5 centimeter, so minus of 0.6 into 5 plus 12. So here that is 9 per second. Okay, so the velocity gradient 9 per second, and the shear stress tau that is equal to mu into du by dy at y equal to 5 centimeter. So mu that is 0.6 into du by dy that is equal to 9. Okay, so from here this will be equal to 5.4 Newton per meter square. So this, in that way we calculate the velocity gradient and shear stress. The weight of a gas is given as 17.658 Newton per meter cube at 30 degrees Celsius and at an absolute pressure of 29.43 Newton per centimeter square. Determine the gas constant and also the density of the gas. You have to calculate the value of gas constant and the density of the gas. So what is given? Omega, that is specific weight 17.658 Newton per meter cube. Temperature that is 30 degrees Celsius. If you want to calculate it into Kelvin, you have to add 273 Kelvin plus 30, that is 303 Kelvin. Absolute pressure that is given 29.43 Newton per centimeter square. So that is equal to 29.43 into 10 to the power 4 Newton per meter square. You have to calculate the density rho and the gas constant R. So how to calculate that? So we know that omega that is equal to rho into g. So from here rho equal to omega by g. So what is the value of omega? That is 17.658 and g that is 9.81. This is the gravitational acceleration. So the answer will be 1.8 kg per meter cube. So this is one answer. Now if you want to calculate the gas constant, we know that the ideal gas equation PV equal to mRT. So from here R that is equal to PV by m into t. So just put the value. So P that is 29.43 into 29.43 into 10 to the power 4, and that is v by m by v, that is rho. So rho, what is the value of rho? That is 1.8 into 303. So the answer will be 539.6 Newton meter per kg Kelvin. So this will be our answer. So thank you.